Hello everyone. So now again we have just here for the another part of chapter electricity, that is part C, in which we will cover the topics Ohm's law, that is tells us the relation between voltage and current, and how we'll just find out the resistance and what do you mean by resistivity. So what are the learning objective we are going to cover in this video, that is how will you state Ohm's law and the graph between voltage and current, and after just finding out the resistance from the voltage current graph, we will define it, what are the units of that resistance. There are so many factors, there are 4 factors basically which are affecting the value of resistance. What are those factors, how they are depending. Then the resistivity, what is resistivity, how will you find out the formula and the units as well. And then some of the numericals for you, and don't forget to solve and reply. So let's begin. Ohm's law. In previous 2 video, if you have not watched, kindly do watch. So in the previous video, we have learned about the current and the potential difference. Those 2 quantities will help us to find the relation between the two, that is potential difference V and the current, and how they are directly proportional. You will observe that as you are increasing the voltage or the potential difference, what happens that will result the change in current in the same manner. But the condition should be what? The temperature should not fluctuate. The temperature should remain constant. So Ohm's law, that was given by George Simon Ohm, and to honor him, the name has been given Ohm's law. So it states that potential difference is directly proportional across the ends of a conductor to the current, provided the temperature that remains constant, remains same. And as you can see, the mathematical expression, if you write for the same, the V directly proportional to I. Whenever we have to remove the proportionality sign, we always have to deduce a constant, the proportionality constant, that is known as V equals to IR or RI, where R is the proportionality constant in this relation, that is known as resistance of the conductor. So we can find out here I equal to V upon R, and R can be rewritten as V upon I, the ratio of V and I. I hope you people know how to find the slope of the graph given. If you find the voltage current graph, and then by using that slope formula, you can find out the current. If not, just do comment, and definitely I will make one video for numericals and for the slope as well. And the value and the units for the resistance that which you use it, what? Ohm. The symbol you can see over here, that is ohm, that is a unit of resistance. So the resistance is what do you mean by the resistance? Resistance, that is the property that obstruct, that resists the flow of charges, that resists the flow of electrons through them. As more resistance we have in the conductor, the current will be slow, because they are inversely proportional. More of the resistance, less of the current. Less of the resistance, more of the current. So a conductor should have less resistance so that the current should flow smoothly. So resistance, as we have seen the formula for resistance, that is resistance can be written as V upon I. So if you have to write the resistance as 1 ohm, you have to, if you have to define resistance, so resistance is said to be 1 ohm when how much potential difference? Potential difference should be 1 volt, and the current should be how much? That should be 1 ampere. So 1 ohm can be written as 1 volt upon 1 ampere. And as already I told you, as you increase the resistance, the current will be decreasing. So if the resistance is double, the current will be half. If the resistance is half, the current will be double, and vice versa. Now if you see that if you just observe, take a pause, just pause the video and just observe the graph properly, and just find out what is the relation between the current and the resistance. You can find out that as the current, in the first case, you will see that the current is more, because the current is shown here 5 ampere 400 volt, if you just check the value, and the resistance is set, say 20 ohms. The second case, if you see here, for the blue line, the 100 volt is there, but the current is shown here 2.5, means we have just reduces the current here. So what is happening here? The resistance is double. The more of the resistance, less of the current. So from this given graph, you can conclude this as well, right? So this is a relation that you can find, and these kind of questions may be also been asked, not by given the value, but by the graph observation also, means after observing the graph as well, you should know how to answer that question. So, does anything which are affecting the value of resistance? Yes, we have some value which are affecting the value of resistance, and that is what there are four factors we have: length of the wire, area of cross section. The third is material of the conductor. This is one more actually the temperature, which we generally discuss more in detail in senior classes. But temperature also is one of the factors that affect the resistance. But let's see, you have to discuss these three. First of all, the material of the conductor. Material means the nature of the conductor. If you change the conductor, if you're changing the material, obviously the resistance will not be same, it will be different. The length in the area, and this is in little, you can say detailing. Why? Because these two factors which we will use in the derivation, or the small derivation. So resistance is directly proportional to length. Directly proportional means as we're increasing the length of the wire, that will increase the resistance value as well. Area, it is inversely proportional to the area of cross section. You increase the area of cross section, the resistance will be smaller. So if we'll ask that as resistance is directly proportional to length, which that wire you will prefer, the shorter or the longer wire? Obviously, we will prefer the shorter wire. Why shorter wire? Because the length is small. Yes, very good. And so that will the length is small, and that will resistance will be small, and as resistance is small, the current will be high. On the other hand, if you just check out for the area, it is inversely proportional. So which wire, thicker or thinner? The thicker wire we will consider. So thicker wire, the thick wire, jitna thick wire hoga, jitna mota tar hoga, what will happen? The resistance will be small. The resistance will be small, and that will help to increase the current. So we'll prefer shorter and the thicker wire. Okay, let's proceed now. By using these two, you can say factors, the length and the area. Now R is directly proportional to length, mathematical expression, and R is inversely proportional to area. So when you combine these two, what will happen? R is directly proportional to L by A, right? And that will, if you remove the proportionality sign, that will be equal to, we will remove the proportionality sign, we have to introduce a constant. What is the constant here? The constant is resistivity, the rho. You name it as you can say the symbol is, it is resistivity. The symbol name is rho. So rho is the constant of proportionality that is known as resistivity. And the units for this resistivity is what? Ohm meter. That is ohm meter. So you can say the resistance is said to be that will be equal to resistivity if a wire, we have a 1 meter length, and we have the area of cross section for that wire is 1 meter square. And the way you can say it is very obvious, because the conductor, they are very good to flow the electron, to flow the charge. So conductor will have low resistivity. On the other hand, insulator, in which the current doesn't flow easily, so they will have high resistivity. The value is like 10 to the power 12 to 10 to the 17. The range is like this much high, right? The resistivity, now the student, they just get confused. The resistivity actually is it is the resistance, you can say, but the length, if the length of the wire is 1 meter, the area of cross section is say 1 meter square. And you know, one more very that interesting fact about this, that resistivity, resistance depends on the dimension, because length and area we have just checked out, but the resistivity doesn't depend on dimensions, it will remain same for any dimension, but it just only depends on the nature. Obviously, the nature of the conductor, the material will be changed, the resistivity will be changed. For a particular the wire, for a particular material at a particular temperature, resistivity will remain same. And it remains same, as I told you, it remains same for a particular substance at a specific temperature, irrespective of the dimensions, but the value of resistance actually changes with temperatures. Temperature change, yes, they will change, but dimensions with the basic difference. The question you may been asked, you may have to give answer for that, like excuse me, that resistance, so what is the difference? So difference is what? Resistance, that is, you can say, depends on the dimensions. Resistivity, that also depends on you can say that doesn't depends on the dimensions. And the units of resistance is ohm, and the resistivity is ohm meter. This question, it was asked the earlier in exams, so kindly just check it out. Let's do the numericals, my favorite part for the numericals. Calculate calculate the resistance of the wire. Potential difference is 100 volt and the current is 10 ampere. Simple. A simplest question, that is which law? Ohm's law. V equal to IR. What is V? 100 volt. What is current? 10 ampere. And the resistances are equal to V upon I. That will be 10 ampere. Okay, that will be there. This are related to resistivity. Resistance of a metal is say 10 ohm. The radius is say 0.1 centimeter. Length we have to find, and the resistivity is also given. So which formula? I hope you just got it. Yes, you are just correct. That is R is equal to rho L by A. What is R? 10 ohm. What is resistivity? 15 to minus 8 ohm meter. What is length? We have to find. What is area? Now area is the one that you have to find out. So what is the radius given? 0.01 centimeter. Convert into meter. Always remember SI unit, or convert into meters. That will be 0.01 into 10 to the minus 2 meter. Now, what is the area? Pi r square. What is the cross section of the circle? That is pi r square. Pi 3.14 or 10 to the 7, and the radius 0.01 10 to the power minus 2. You can say you can say meter, right? So by using this formula, and we can find out the length, that will be 0.602 meters, right? Easy. Only you have to take care of calculation, nothing else. So just pause the video, take a click, solve the questions. For the numericals, I have given the answers also here. And don't forget to share the answer with me. Let's see how many of you will try. Then all the very best for this. And any doubt, you may comment in that, you can say comment box. You can just message me. Definitely going to help you. So thank you so much. I hope Ohm's law and the resistance and resistivity is quite clear to you, the factors and all. So keep watching, keep supporting. Thank you so much. And don't forget to subscribe the channel. Thank you. See you very soon. Take care. Bye-bye, everyone.